In this video, I'm going to go through the answers to the 5.3 exam questions. The first question is, what is meant by a covalent bond? The answer is a shared pair of electrons. You have to mention the word shared. You have to mention the word pair of electrons. Okay, there is a longer definition, the electrostatic force of attraction between a shared pair of electrons and two bonding nuclei. But when you're only asked for 1 mark, they just want a shared pair of electrons. The next question, you're asked to draw a dot and cross for boron tribromide. Okay, boron tribromide, that tells me I've got 1 boron and I've got 3 bromines. When I'm trying to decide what type of bond I'm going to draw, am I going to draw a single, a double, or a triple? Okay, I look at boron, which I've got in the center. I know it's in group 3. It can only form 3 bonds. If it can only form 3 bonds and it's bonded to 3 atoms, then all of those bonds must be single. So I'm going to draw 1, 2, 3. Okay, and that's all of boron's atoms drawn. They're all involved in bonding. And then bromine is also going to contribute 1 electrons to each of those bonds. Bromine has got 7 electrons in total. So bromine has another 6 electrons that will not be involved in bonding. Okay, you'll see that boron only ends up with 2, 4, 6 electrons, so it doesn't have a full outer shell. But because it's only got 3 outer shell electrons, the most it can form is 3 bonds, even though it doesn't end up with 8 electrons. CO2, we've seen this one already, okay? Carbon is in group 4, it wants to form 4 bonds. It's only bonded to 2 atoms, which means it needs to form 2 bonds with each of those atoms. That suits oxygen, okay? Oxygen's in group 6, it wants to form 2 bonds, so it's happy to form that double bond with carbon. So carbon's 4 electrons, 1, 2, 3, 4 crosses drawn. Oxygen's got 6, 2 dots to show the double bond, and it's got 4 dots as lone pairs, okay? So 4 electrons as lone pairs that are not involved in bonding. When I'm showing nitrogen, okay, nitrogen's in group 5, it wants to form 3 bonds. It's only got 1 other atom, okay, another nitrogen atom to bond with, so it must form those 3 bonds between the 2 atoms. So you've got a triple bond between the 2 nitrogen atoms, 5 electrons in total for nitrogen, so I've got 5 dots and I've got 5 crosses. The next one, and they've drawn the structure for you in this case, so they've shown that it's a double bond between carbon and oxygen. They just want you to draw the dot and cross. So I've got carbon, I've got oxygen, and I've got 2 Cls, okay? I know I'm drawing a double bond, so which means carbon is contributing 2 electrons to the oxygen and it's contributing 1 to each of the chlorines. Oxygen's also going to contribute 2 electrons to that bond. Oxygen's got 6 in total, so it's got another 4. Chlorine's contributing 1 electron to the bond with carbon, but it's got another 6 electrons not involved in bonding, which I'm going to jot in now. Okay, so carbon ends up with 8 electrons in its outer shell. It's forming 4 bonds, which is what it wants. Oxygen wants to form 2 bonds. It's forming those 2 bonds with carbon. Chlorine's happy to just form 1 bond. Oh, sorry, I didn't draw. Oh, I shouldn't have drawn. Sorry. I'm going to use something else that are not crosses for chlorine because that's confusing. Sorry, I'm going to use open circles for chlorine. I'm going to show 1 electron bonding with carbon and the other 6 electrons around the chlorine atoms. Next up, it says you've got carbon monoxide, and it tells you that you've got a triple bond. So carbon monoxide, so it's carbon bonded to 1 oxygen. It tells you you've got a triple bond, and it tells you that one of those bonds is dative covalent. Okay, so one of those bonds contains 2 electrons that have each come from the same atom. You need to construct dot and cross to show the electrons. So if I'm drawing carbon and oxygen, okay, I've got a triple bond. Only one of them is dative. So the other 2 bonds are normal bonds. So I'm going to draw 1 electron from carbon, 1 from oxygen, 1 from carbon, 1 from oxygen. Okay, for that third bond, both electrons in the third bond are coming from the same atoms. I'm either drawing 2 dots if they're both coming from oxygen, or 2 crosses if both electrons are coming from carbon. Okay, to form a dative covalent bond, you need to have a lone pair. When we draw oxygen, as we did above, we see that oxygen, when it's drawn, has lone pairs. It's got electrons that are not involved in bonding. Every time we've drawn carbon, all of its electrons are used in bonding. Carbon doesn't have lone pairs. So if you're going to form a dative covalent bond, it's going to come from the atom with the lone pair. It's going to come from oxygen. So I'm going to draw 2 dots to show the dative bond is from oxygen. Oxygen's got 6 electrons in total. I've only drawn 4. It's got another 2 electrons that are not involved in bonding at all. Carbon's got 4 electrons. I've only drawn 2. It's got another 2 electrons that are not involved in bonding. Carbon ends up with 8 in its outer shell. So does oxygen. The next example, you've got sodium carbonate, and they want you to draw the CO3 2-. They have drawn the displayed CO3 2- ion for you, which is a big help. Okay, you can see that carbon has formed 4 bonds, 2 single bonds with oxygen, and a double bond with oxygen. So I'm going to start by drawing that. I'm going to draw my carbon. I'm going to draw my oxygens. Okay. Carbon's got 4 electrons. It's forming 1 bond with this oxygen, 1 bond with this oxygen, and a double bond with this oxygen. So all of carbon's electrons have been assigned. I'm then going to go to this oxygen here. Okay, it's forming a double bond with carbon, so it's contributing 2 electrons to that bond. It's got 6 electrons in total. I've only drawn 2. So the other 4 electrons I'm going to draw over here. So I've drawn my electrons for oxygen and I've drawn them for carbon. Now I've got these 2 oxygens remaining, and in the displayed formula you can see that they both have a negative charge. It says to use different symbols for electrons from carbon and oxygen, which I've done so far, and any extra electrons. The extra electrons they're talking about are represented by the fact that you've got 2 negative charges here. Okay, so if you've got a negative charge, it means oxygen has gained an electron. Okay, and you can see here that you're talking about sodium carbonate. So we know when sodium reacts, sodium's metal, it's going to lose 1 electron. You've got 2 sodiums. So you had 2 sodiums, which each lost 1 electron, and those electrons have been gained from oxygen. So when I'm drawing my electrons here, it's not just oxygen's and carbon's electrons I'm drawing. I've also got 2 extra electrons I need to assign that have come from sodium. So when I'm looking at this oxygen, okay, I can see that it's formed a single bond with carbon. Okay, carbon's contributed 1 electron to that bond. This oxygen is also going to contribute an electron to that bond. Oxygen has another 5 electrons because it's got 6 in total. So I'm going to draw 1, 2, 3, 4, 5. Okay, this oxygen is also doing the same thing. It's contributing 1 electron to the single bond, leaving it with another 5 electrons. Okay, but now I must also draw my extra electrons. Okay, both of these oxygens have a negative charge. They've both received an electron from sodium. So I'm going to draw in another electron. I'm going to do it in red to show the extra electron that they have gotten from sodium. Okay, so this oxygen ends up with 2, 4, 6, 8 electrons. This has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8. So all atoms have a full outer shell. You've got 2 extra electrons in there from sodium, which is why you've got 2 negative charges, and why this oxygen was happy to just form 1 bond with carbon instead of 2, because it had already picked up an extra electron from sodium. The last example, they are talking about lithium aluminium hydride, and they want you to draw the AlH4- ion. This is quite a tricky example, just because you've got aluminium and you've got hydrogen, and aluminium, you know, is a metal, and hydrogen is obviously not a metal. So your first instinct might be that you're drawing an ionic dot and cross diagram, but you are not. You are drawing a covalent dot and cross diagram. Okay, and the clue to that is they're telling you that the whole thing, AlH4, is an ion. Okay, it's a polyatomic ion, and in your polyatomic ions, the atoms are covalently bonded. I'm going to start by drawing Al. Okay, so I know I've got my aluminium in the center. Aluminium's in group 3, so it's got 3 electrons in its outer shell. So I'm just going to draw 3 electrons in its outer shell, and I'm going to draw it bonding to 3 hydrogens initially. Okay, each hydrogen is going to contribute 1 electron to those bonds, and you would have AlH3. Okay, but it's telling you it's AlH4-. That minus tells me that it gets an extra electron, and I can see where it's getting that electron from. Okay, it's bonded to lithium. Lithium's in group 1. Lithium's going to lose 1 electron. So lithium loses an electron, and then that extra electron can be picked up. Okay, so to represent that I've got an extra electron, I'm going to draw it in red. Okay, so I've got an extra electron. That means that aluminium can now form 4 bonds, and it can now form a bond with another hydrogen. Okay, without that extra electron, aluminium could only form 3 bonds with hydrogen, but once it has that extra electron, it can form a 4th bond, so you get another bond with a hydrogen. It's important that I'm using a different symbol to represent that extra electron, so I've drawn it as a red circle. Okay, because aluminium is gaining an electron, that's why you end up with a negative charge on the ion overall. But yeah, that is a slightly harder one just because you've got aluminium and hydrogen. You might have been expecting ionic bonding. It is in fact covalent bonding.